Let's move on to lesson 7 in chapter 8, and we're going to solve one-step inequalities. You will notice many similarities to solving equations. Your answer just means something different. So in this first one here, x minus 8 equals negative 12. We would add 8 on both sides, and x would equal negative 4. Now, if we do that to an inequality, add 8 on both sides, your answer is x is greater than negative 4. That means your answer is not negative 4, it's any number greater than 4. So that's where it changes the meaning of our answer. All right, let's do a few examples here at the next part of this page together. In number 1, we would add 5. And g would be less than negative 3. So when you make your number line, I always put the negative 3 in the middle. 2, negative 1, negative 4, negative 5. I put 2 numbers on each side. Remember, we're going to use an open circle. That shows that negative 3 cannot be an answer, but it is your starting point. G is less than negative 3, so we would be going to the left. So anything less than negative 3 could be a solution. Okay, let's look at number 6. We would subtract 8.6 on both sides, which means P is less than or equal to negative 17.7. Now notice this one, the P is on the right side, so that's why you have to read it from right to left. So P is less than or equal to negative 17.7. Negative 17.6, negative 17.8. I can't fit much on this number line. We would do a closed circle. Since it does have that line underneath it, it could be equal to it. And P is less than, so it'd be going to the left. All right, if you turn the page, for multiplication and division, most of them are the same, unless you come to a negative inverse. If you're going to multiply by a negative or divide by a negative, you must switch your symbol. Okay, and here's an example why. If we divide by negative 5 on both sides and keep the symbol the same way, it's saying that x is less than negative 5. Well, if you plug in a number that's less than negative 5, you'll notice your inequality does not stay true. If you flip it to x is greater than negative 5 and pick a number greater than negative 5, it will work out. But that's only if it's a negative and you're multiplying or dividing. So if you look at 10, 11, 12 here, this one you would not switch because you would divide by a positive 5. This one you would multiply by a negative 11, so because it's a negative, you would switch your sign. Okay, same with number 12, and we'll do that one together. We will switch this one because we're going to divide by a negative 4. So we're going to make it m is less than positive 4. And if you pick a number that's less than 4, let's say 3, and plug it in, you would do negative 4 times negative 3, you get negative 12. Is 12 greater than negative 16? Yeah, so it does work out. If you would pick a number that's greater than 4, like 5, you're not going to get a true statement. All right, and then we'd graph it. So 4, 5, 6, 3, 2. That's going to be an open circle, and it's less than 4, so it's going to the left. So again, you're only switching your symbols when it is a negative and you're multiplying or dividing in an inequality. Okay, let's do a word problem together. And number 27, Antonio has at most $18 to ride go-karts and play at the state game fair, or the state fair. The go-karts cost $5.50. Write an inequality that can be used to determine how much he can spend on games. Okay, well the $5.50 is the go-karts plus the games, and he doesn't want to go over $18, so that has to be less than or equal to 18. So if you solve this, you would subtract 550 on both sides. And that's going to be G is less than or equal to $12.50. So what does that mean? He has $12.50 or less to spend on games. If you look at 29, it says $13.50 per hour. So remember, that would be multiplication. Anytime it's per something, that's just for one. So you'd want to times that by the H's. And he wants to earn at least, so it could be greater than or equal to $337.50. And then you would just divide by $13.50 on both sides.